First of all, we need to talk about sign diagram. When a linear factor has an odd power, there is a change of sign about that zero. When a linear factor has an even power, there is no change of sign about that zero. For the first derivative, when f prime of a equals 0, the point a f of a could be maximum point or minimum point or stationary inflection point. When f prime of x greater than 0 for all x in S, the function f of x is increasing in S. When f prime of x less than 0 for all x in S, the function f of x is decreasing in S. Here is the diagram about first derivative. When f prime of x less than 0, you see the graph, this two is decreasing. And for f prime of x greater than 0, this two is a increasing function. When f of x equal to 0, it could be maximum value or minimum value, or could be stationary inflection point. Now let's go to guided practice 2. Find the interval where the following functions are increasing or decreasing and classify all the stationary points. Stationary points means minimum, maximum, or stationary inflection. Increasing means we're looking for the interval where f prime of x greater than 0. Decreasing interval means f prime of x less than 0. So first step, you need to figure out the derivative. You will get negative 3x squared plus 12x. We need to factor this. You will get negative 3x and x minus 4. Then we draw sign diagram. First of all, you have to get the roots. x1 equals 0, x2 equals 4. So 0, here's 4. Choose any number you want. Basically, we choose 0, 1, 2, 3. Here's 0, so we cannot choose 0. I use 1. I plug 1 into this factor form function. When you plug in 1, negative 3 times 1 is negative. X minus 4, that's 1 minus 4 is negative. Negative times negative equals positive. So I will put this is a positive. Check this 0. Where you get this 0? You using this x. Single factor. That means all the power, you need to change the sign at this 0. For the 4, the factor is still single factor, so we change the sign. Therefore, you could say this is a decreasing and here is a increasing, then decreasing. Therefore, for this 0 will be minimum. For this 4, it will be maximum point. So we write down increasing interval, that is from 0 to 4. For decreasing interval, you will get from negative infinity to 0 and from 4 to positive infinity. And a minimum point, that is at x equal to 0. And a maximum point that is at x equals to 4. Now let's go to B. We still get the derivative of f of x. You will get this 12x to the third power minus 6x squared. Still factor 6x squared. We factor 2x minus 1. Then you will get the x1 equals 0 from this x squared. We set up this equal to 0, you will get the x equals 1 over 2. So we draw number line 0, 1/2. We will choose 1 here. Still plug into the factor formed function. We plug in 1, this will be positive. Plug in 1, positive. Positive multiplied by positive, still positive. Check 1/2 as roots. Where you get that, the factor will be this. 2x minus 1. That's a single factor, so we change the sign. This is a negative. Then we go to this 0. Where you get this 0, you get from x squared. This is a even power, the sign stay. No sign change. Therefore, we can write down the increasing interval. That's over here. This is a decreasing. This is a decreasing. So for increasing interval, that will be 1/2 to infinity. For decreasing interval, that is from negative infinity to 0. Then from 0 to 1/2. For this 0, it will be stationary inflection point. This 1/2, you could see going down then going up. Definitely that's a minimum point. Let's go to guided practice 3. Consider f of x equals this. Show that f prime of x equals this. And draw the sign diagram. So for f prime of x equals, make sure you have to do quotient rule. So we have x squared minus 3x minus 4 squared. We got to do 3x plus 4. We do derivative. Then times x squared minus 3x minus 4. Then here's minus 3x plus 4. You stay. Then you multiply by x squared minus 3x minus 4. We do derivative. Keep going. Denominator, I can factor x minus 4, x plus 1. So we get the x minus 4 squared, x plus 1 squared. Derivative for 3x plus 4, that will be 3. This one, you will get the x squared minus 3x minus 4. So we do distributive property for this. You will get the 3x squared minus 9x minus 12. The derivative for this, that is 2x minus 3. Then 3x plus 4. We do FOIL first. Then using this negative sign, do the distributive property. So we have 6x squared minus 9x plus 8x minus 12, which means 6x squared minus x minus 12. Don't forget I have negative sign here. So you get the negative 6x squared plus x plus 12. Then combine like terms. you will get negative 3x squared minus 8x. Then denominator will be x minus 4 squared x plus 1 squared. That equals negative x take out 3x plus 8 over x minus 4 squared x plus 1 squared. Then draw the sign diagram. If you have a rational function, you will get the roots and also vertical asymptote line. You make a top equal to 0, you will get the x1 equal to 0, x2 equals to negative 8 over 3. Then you make a denominator equal 0, you will get the x3 equals 4, x4 equals negative 1. This is a vertical asymptote line. And we can draw sign diagram. You have 0, negative 8 over 3, negative 1, and here's 4. For negative 1, that's a vertical asymptote line. 4 is a vertical asymptote line. Choose a number, plug in. Let me choose 1. I plug into this function for this 1. That's negative, positive. Denominator is a positive because you square. Since I only have one negative, this will be negative. Then I check for this 4. Where you get this 4? From here. And this is a even power. 2 is even number, so you stay still negative. Then for this 0, single power, you change the sign, positive. Check negative 1, even power, so you stay. No sign change at negative 1. For negative 8 over 3, that's a single power, still change sign. Then you will see this is going down, going up, and going down. Then this one is going down. So you could say that the increasing interval will be from negative 8 over 3 to negative 1. Union set from negative 1 to 0. For decreasing intervals, it will be from negative infinity to negative 8 over 3. From 0 to 4. From 4 to infinity. For the stationary point, that means minimum, maximum, or stationary inflection. For vertical asymptote line, nothing to do with stationary points. So just check this. This will be minimum point. This 0 will be maximum point at x equal to 0. Now let's go to guided practice 4. Consider f of x equals this. We need to show that we're still using the quotient rule. So x squared plus 1 we square. And 4x to the derivative x squared plus 1. Then here's minus. Then you have 4x times x squared plus 1 to the derivative. You will get the denominator stay x squared plus 1 squared. 4x, that's 4 times x squared plus 1. Derivative for this is 2x, so minus 8x squared. Distributive property 4x squared plus 4. So you have negative 4x squared plus 4 over x squared plus 1 squared. So you get negative 4 take out x squared minus 1. X squared plus 1 squared. Then you need to factor the top. You get negative 4x plus 1, x minus 1 over x squared plus 1 squared. Then we need to draw the sign diagram. Make a top equal 0. We got the x1 equals to negative 1, x2 equals 1. Denominator never be 0. So we just keep this. x1 equals negative 1, x2 equals 1. Then we choose 0, plug in. You will get, here's a negative, positive, negative. This is a positive. So you will get a positive. For 1 and a negative 1, both is a single factor, so change the sign like this. Therefore, increasing, that is from negative 1 to 1. For decreasing, that is from negative infinity to negative 1, and from 1 to positive infinity. So you could say this is going down, going up, then going down, which means negative 1, this point will be minimum point. This point will be maximum point. Now let's go to guided practice 5. Consider this. Show that. So we still use a quotient rule. X squared. E to the negative x power, we do derivative times x, minus e to the negative x power times x, the derivative. E to the negative x power, when we do derivative, for any e to the what power, you will get itself. Remember, that's the rule. Then you have to do the derivative for this negative x, will be negative 1. So you get the e to the negative x power times negative 1, then times x, minus e to the negative x power times 1 over x squared. So we organize. You will get the x squared. Negative e to the negative x power times x, minus e to the negative x power. We take a negative e to the x power outside, get the x plus 1, then x squared. Then we draw the sign diagram. Remember, e to the negative x power always greater than 0. Never be equals to 0. So we have x1 equals negative 1, x2 equals 0. This is a vertical asymptote line. So you have here's 0, negative 1. Vertical asymptote line. We choose 1, plug in. So you get negative e to the negative x power will be negative. 1 plus 1, that's a positive. Denominator is still positive, so we get a negative here. Then for 0, that's a x squared, even power, so the sign stays. For negative 1, that's single power, we change the sign. So we have going down, and going up. For decreasing, that is from negative 1 to 0. Union set from 0 to infinity. For increasing interval, that from negative infinity to negative 1. You could say for negative 1, this will be the maximum point because it's going up then going down. Let's go to guided practice 6. This is the one. Show that the function has a local minimum and this is the only turning point. Whenever you say logarithm, make sure you get the domain. Domain will be the argument greater than 0. So for the derivative for this function, you will get the derivative for x minus the natural log of x we do derivative. You will get the 1 minus 1 over x. We put this together, multiply by x. You will get the x minus 1. Now let's draw the sign diagram. Before that, you have to get the roots. We make a top equal 0, x1 equals 1. Make a denominator equal 0, x2 equals 0. That's a vertical asymptote line. So you will get the 0, here's 1. Remember the 0 is a vertical asymptote line. But your domain is x greater than 0. Therefore, I will say, let me choose 2, plug in. 2 minus 1 is a positive. This is a positive. Positive over positive, still positive. For the 1, that's single power, here's a negative. Therefore, you could say this is going down, this is going up. Show that the function has a local minimum. We use this sign diagram to show the local minimum at x equals to 1. This is the only turning point. Check this sign diagram. You could see this is the only turning point because your domain is x greater than 0. Let's go to B. Hence, prove that natural log of x less than equal to x minus 1 for all x greater than 0. Because from this sign diagram, we know the f of x greater than equal to 1. Because 1 is minimum value, which means x minus natural log of x greater than equal to 1. So I move this one over here, 1 to the left side. You will get the x minus 1 greater than equal to natural log of x. In other words, I can write out natural log of x less than equal to x minus 1. That's it. That's how you prove. Let's go to guided practice 7. Consider this. Touch the line with the equation y equals 9x plus 2 at the point 0, 2. Has a stationary point at -1, -7. Find the p of x. Whenever see the point, that means we need to plug in. So p of 0 equals a times 0 to the third power plus b times 0 squared plus c times 0 plus d. It will be equals to 2. This is a 0, so we can get the d equals 2. After you get the d equals 2, remember this. Y equals 9x plus 2. That means the derivative of 0, that equals 9. Because for derivative means the slope of a tangent line. This slope, that's 9. First of all, we need to figure out the derivative of p of x. That is, drop down this, that minus 1. So we have 3ax squared plus 2bx plus c. Then we plug in 0 because it's at 0, 2. You will get the 3a 0 squared plus 2b times 0 plus c. It has to be equals to 9. 0, 0, so we get the c equals to 9. Get the d and c. This is the first step to get the d. This is the second step to get the c. So we get the third step, stationary point at -1, 7, which means I will plug in to this derivative function p of -1 that will be 0. So I plug -1 into this function. You will get 3a -1 squared plus 2b times -1 plus c equals to 0. You will get 3a minus 2b. C is 9, so let me say plus 9 equal to 0. Also, -1, -7 is the point on the graph. In other words, I can write down P of -1 equals -7. So we plug in a times -1 to the third power plus b times -1 squared plus c times -1 plus d equals to -7. Then we plug in d equals 2 and c equals 9. You will get -a plus b minus 9 plus 2 equals to -7. You will get the -a plus b equals to 0, which means a equals to b. If a equals to b, then you can get the a plus 9 equals to 0. A equals -9. And a b equals -9 too. Other words, we can figure out P of x equals -9x third power minus 9x squared plus 9x plus 2. This will be the function for P of x. Let's go to guided practice 8. Consider f of x equals that. So we will get the f prime of x e to the sin x times cosine x. As we know, this always greater than 0. So you have to do the sign diagram for cosine x. We go to quadrant. Remember, all students take calculus. For cosine, positive, positive. This is a negative, negative. 0, pi over 2, pi. 3 pi over 2 and 2 pi. So we get the increasing interval that's positive from 0 to pi over 2. Also from 3 pi over 2 to 2 pi. For decreasing, that is from pi over 2 to pi. And then from pi to 3 pi over 2. This is increasing, then going down. That means pi over 2, that's the maximum point at x equals pi over 2. This is going down, then going up. So minimum point will be x equals 3 pi over 2. For this pi, the sign didn't change, means the pi will be stationary inflection point. X equals to pi.